Okay, hello, and welcome to the Noisebridge Python class. This is a free class at Noisebridge Hackerspace in San Francisco, California, USA, that happens on Mondays at 7 p.m. And it is Monday and it is 7 p.m., so we're about to have a class. My name is Travis Briggs. I'm the instructor for the class, and we have a few people with us here in person at Noisebridge. So let's begin. Today's class, this is lesson 3. With the current class schedule, we actually repeat each lesson 2 or 3 times. It's actually the 3rd time we've done lesson 3 now in this series. Because we're doing like 1, 2, 3, 2, 3, 4, 3, 4, 5, etc. So I think some of you will have some familiarity with this material. And yeah, other than that, I think we're ready to go. So let's see, what are we going to talk about today? Some building blocks of Python programs. We're going to talk about like literals, expressions, and statements, and how they relate to each other. And that the entire section on that is really just designed to help you understand how to read code and understand how to think about substituting in values in different places in code blocks so that you're not thinking like, oh, I can only have a string here. Like, no, you don't. It's not just a string. It's any expression can go there. Stuff like that. Then we're going to talk a little bit more about data structures, dictionaries, lists, tuples, and sets. Someone is hammering in the next room over. Sorry about that. We'll also discuss exceptions. Let's face it, the world is messy and sometimes things will go wrong. We're all familiar with the basic idea of a computer error. So in Python, we use exceptions to precisely define, reason about, and handle errors. So we'll talk about some stuff about exceptions. All right, let us begin with literals, expressions, and statements. So a literal is a specific value, a specific piece of data in code. So here we have a few literals, 42, an integer literal, true, which is a Boolean literal, hello world, a string literal, and then we have this list literal, which inside of it also contains string literals. We can assign literals to variables, which we've seen before, and there's not too much more to know about literals. An expression is any bit of code that evaluates to a value in place. So when Python sees an expression, it calculates what the expression evaluates to and sort of replaces the expression with that value. So when it sees 4 plus 2, it evaluates to 6. A function calls an expression. So this expression, sum 1, 2, 3, 4, evaluates to 10. And expressions can be combined and can be the building blocks of other expressions. So here we have a longer expression where we have like the sum, minus 4, plus 2, etc., which kind of makes sense if you're thinking about like basic algebra, right? Like if you've got like x plus 2, you can put like plus 4, then you put like minus 6, and you go plus 7, you just keep going as long as you want, right? So that's kind of the idea here. So here we have some examples of expressions. So this is a statement, which we're about to cover. We set D to this dictionary literal. Then we set foo value equals D foo, and then I'm supposed to update this. So then foo value equals D foo. Foo value is an expression. It's just an expression consisting of a single variable. So then here, like, what are all the expressions here? Like, this literal is also an expression. Literal. Here's an expression. Sum on its own, that's an expression. This max is an expression. And then the variable here is also an expression. So basically, the idea is just that like you can combine expressions. If you see an expression or a value, you can replace it with an expression, etc. All right, so now an assignment is not an expression. This is where it gets where there's actually a roadblock here. It's like a speed bump, right? An assignment is not an expression. Assignment is a statement. In Python, you can think of statements as basically a code that's on its own line in a Python program. A piece of code that's on its own line. So here, x equals 4 plus 2. The expression 4 plus 2 is first evaluated to 6 and then stored in the variable x. So x doesn't hold 4 plus 2, right? X holds 6 because Python first evaluated 4 plus 2. And especially think of the right side of that assignment was like a function call. Python will need to call the function to figure out what to store in x, right? So it makes sense that it evaluates the expression on the right side before assigning it to the variable on the left side. And if and for are also statements which have blocks attached to them. Blocks contain statements. Don't worry too much about that. It's kind of just obvious if you see the code. So here's an assignment statement, x equals 10. Then we have an if statement. That's a statement. And it just prints x is greater than 5. And then we have a for loop statement for character in hello. Print the character. If we run this, x is greater than 5, then we get the HELLO. So a statement has to live on its own line, right? Which is why you can't put a statement in a place where you can put an expression. So here's some more expressions. We can print the expressions. This is an error because I'm saying sum of this plus x equals 42. Well, x equals 42 is not an expression. X equals 42 is a statement. So I can't use it in the place where I would put an expression. I can put 55 here, that's fine. I can put len 1, 2, 3, that's fine. But I can't put x equals 42 there. It has to be on its own line, like this. Similar problem here. X equals 3 plus if 4 greater than 2. This is just kind of nonsense. You can't have an if statement in the middle of another expression. It's a statement. That's kind of the point we're trying to make here. And now, this is the Venn diagram. And I feel like I should have just started with this, but all literals are expressions. All expressions are statements. Picture the Venn diagram that I'm too lazy to draw. So here, this kind of shows you it, right? 42, just on its own line, right? That's a literal. It's also an expression. It's also a statement. 42 plus 2, this is an expression. It's also a statement. X equals 42, this is a statement. Cool? Y'all get this? Yes? All right. I can run this, it doesn't do anything. Or it doesn't print anything. All right, here's the exercise. Write 5 literals, 5 expressions of various complexities, and 2 statements that use your literals and expressions. So don't just use the ones from the code above. Come up with your own. Function calls are expressions, so you can use those as an expression, as a statement, inside an expression, etc. And that is the exercise. Any questions? Okay, so next I want to talk about none type. So one thing we might notice is that I have print hello here as an expression because it's a function call, so technically it is an expression. But the print statement, a print function, actually returns none. It doesn't return a value. It returns none, which is a special value that means no value. It's like null in JavaScript or null in SQL. It means that either the variable hasn't been initialized or created yet, or that there's some piece of data that we actually don't know the value of. So here I have an example of a list of temperatures for various dates. So we have April 1st, 55, April 2nd, 60, blah, blah, blah. April 4th is 57, and then April 6th is 59. So actually we're missing the value for April 5th. We could just keep it like it is, right, and omit the value, which is a perfectly fine way of handling this. But we could also use none. So we say here, in the second example, we see 2025-0405 is mapped to none. It's just us saying, like, we didn't get a temperature reading that date. None. It's not -1 or 0, because those would be valid temperatures. It's none. And this actually is probably a preferable approach if you were like printing all the dates and the temperatures in a table, because you wouldn't have to say like, oh, does this temperature exist? Does this temperature exist? Because remember, if we access a key from a dictionary that doesn't exist, it's a key error. That's an exception. So that's none. This is probably better because it also means that if someone's looking at this, they might think like, wait, it's missing the data for the 5th. Why isn't it there? It must have been a mistake when I copied it or something, right? But this makes it explicit that like, no, we have no data for that date. And some people might think, yeah, if I don't have a value, I'll just put -1, I'll put 0, -100, whatever. But you might want to put some special value that indicates that you don't have a value, right? Well, that's what none is. It's that special value that indicates we don't have a value. So back to print, the print function returns none. So if we try to do, I'm showing it right here. And any function that runs to completion without returning a specific value will implicitly return none. So if you have a function that gets to the end of the function and it hasn't hit a return statement, that function returns none. So every function returns something, but it might be none if it didn't actually return a specific value. And then we can test for none with is none and is not none. And none is a falsy value. If you remember truthiness and falsiness, none is falsy. So here we have y equals New York, right? And then we have result of print. Oh, this is wrong. So I print y and I store the results of that function in result of print. Then I try to do result of print dot starts with new, right? But this doesn't work because result of print isn't New York, it's none. Print returns none. It doesn't return what it printed. So this is an exception. None type object has no attribute starts with. And actually this is a good exception to get familiar with when you're writing Python. If you see like none type object has no attribute whatever, it means that whatever on the left side of that dot is none. So here it's pointing to this line, result of print starts with new, right? And saying none type object has no attribute starts with. So that's saying like this is none. We can just infer from this error message that result of print is none. Does that make sense? Because it's saying none type has no attribute starts with. Where am I trying to get starts with from? I'm trying to access the starts with attribute on result of print. If result of print had a starts with method, if it was a string, this would work fine. But since it's none type, it doesn't work. None type doesn't have any attributes. It's nothing. There's nothing for the what?
So it's really just another way of saying there's nothing for result of print. It's like a 0.
It's not like a 0 because a 0 is a 0. 0 is a value, right? I'm just trying to explain that when you see this error message, none type object has no attribute whatever, just look in your code. Where am I calling dot whatever? And that's the thing that's none, result of print. Which makes sense because as I told you, when the print function runs, it returns none, right? So none was stored as a result of print, and then we basically did none dot starts with new. So that doesn't work. We'll comment it out for now. None is null. Yeah. And then this function here returns none. It does some math. X equals 2 plus 2. If x is greater than 3, y equals 25. Z equals y plus x, blah, blah, blah. Does a bunch of stuff, but doesn't return anything, right? So what is it going to return? None, right? So if I say n equals returns none, I call that function, and then I print n is none. Then I can do print n is none. That's true. Then I have x equals 42, print x is not none. That's also true. Make sense? Cool. All right, let's talk about dictionaries. Dictionaries map a key to a value. Here we have an albums dictionary that maps strings to numbers. It looks like Beatles albums and the year they were released. We can use numbers and strings, which are the most common, and tuples, as well as other hashable objects as dictionary keys. We cannot use lists or dictionaries themselves as keys. Hashable is like a computer science concept. It basically means that we can reduce all the data in an object to a consistent string that represents that object. And it's irreversible, so I can compress an object into a hash, but I can't get the object back from the hash. But every object that has the same value, everything that's the same thing, will have the same hash. That's how hashing works. But that's really only if you're super interested. It's not really that important for programming in Python. The important part is that you can use numbers, strings, and tuples, and some other things as dictionary keys, but you cannot use lists or dictionaries as keys. And when I try to run this, so here I have fruits. I'm trying to map apple and banana to like this price, and cherries and grapes to this price. This looks reasonable, right? Like, oh yeah, you've got these two things cost that. These two things cost that. This is fine, right? But when I run it, unhashable type list. That's where that hashable thing comes from, right? It's saying like a list is not a hashable type. Because if you have a list and you try to hash it, then someone adds something to it, it's the same list, but now it has a different hash, so it's unhashable. It doesn't matter. You just can't use lists as dictionary keys. That's the most important thing to remember. You can assign any expression as a value that's mapped to a dictionary key. So here, how many dictionaries are in this code? So 2. Guess over here. 1, 2. I'm going to tell you there's 3. So there's this value for the key Russia, this value for the key United States. These are both dictionaries, right? But almanac is also a dictionary, right? Because it's mapping country names to a bunch of data about that country. So this is a dictionary which has string keys, and the string keys map to additional dictionaries. And then we see some inside the country dictionaries, we see like population, which is like a number, capital is a string, largest city is a string, and then cities is just a random list of cities. We're gonna get to tuples real soon. If I can jump ahead if you like. Okay. Okay, so this is my almanac. So yeah, you can have anything, any expression. So remember, like a literal is an expression, right? So I can assign this literal as the value of largest city. I could also assign like New York City 0. A list with one item and get the first item. Now this is just like useless code. It doesn't really do anything useful. It's just kind of, it's just going out of its way to be verbose and like not really accomplish anything. But I could use that too because that's an expression, you know? So that's why we talked about the expressions and everything. Okay. So this is kind of like a programming best practices thing. So we try to make our dictionaries have like a standard shape. And by shape, I mean like, okay, they all have 4 keys: population, capital, large city, and cities. And the population is a number, and it's in the same units, right? Like if I had multiple people and I had height, I wouldn't put 1 in centimeters and 1 in inches, right? Because then it'd be like hard to compare, right? So stuff like that. That's the shape of the dictionary, right? But it's not required. So here's a new almanac where I have the United States is the same as before, and then I have this dictionary, Silly Land. Its population is banana. The capital is 12. You know, like it's just whatever. This I can print it, and guess what? It prints fine. This is valid Python data, right? It's just not very useful when you're writing your program because you're like, why is the city in Silly Land 400, right? Red, or the list red blue? Like, what does that even mean? It's like when you're going through your program, you kind of want to use a for loop to go through all the countries in the almanac and maybe print all their capital cities. So you want the capital city to be in the same place in every dictionary. Make sense? Cool. Sorry if I'm yelling. It's just like a ton of noise today, so. I'm not yelling at you. Okay. And then this is just what I was talking about kind of before. We can use any expression as the value of a dictionary. So here I have pop in millions. It returns a value, or it rounds it if it's requested. And now I'm setting the population to pop in millions time a million. So if I run that, the population still comes out to be 328 million. Because, as we said before, it evaluates this expression before storing the value. Accessing dictionary keys, we use slice notation. So Almanac United States is the United States dictionary. And since the United States is also a dictionary, we can slice further. So we have Almanac United States, and I'm saying take that and get the population out of it, because Almanac United States is a dictionary, right? So we can get the key out of that dictionary. And that's the population. And this is a little bit silly, kind of a silly example, but it is sometimes useful. We can slice with any expression. So here I'm saying print almanac country, which is United States, and then soda, which is pop, and then this function call, get rest of key, which just returns ulation. So when I print this expression, what will it print? And Gene, you're the only one here to answer. Yep, exactly. Because this soda plus get rest of key becomes the string population, and then it searches for that key in the dictionary and gets the population. You try to get the value of a key that doesn't exist, that's an error, key error. Germany is not in the almanac. And if we use a dictionary reference, like, hey, I want the key Germany, and then we assign to it with an assignment statement, we can add new data to the dictionary. So if I add Germany like this and then print it, it's hard to see, but over here, here's Germany now in the dictionary. Okay, more on lists. A list is an ordered sequence of values. The values in a list literal can be any expression. So here again, I have United States as a list. is kind of less useful than a dictionary, but sometimes you might have lists that just like the first item is the population, the second item is the capital, blah 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 blah, and you can see that I'm initializing it with this pop in millions thing again. Then I'm doing get cities, which just returns this list, and when I print it, there's my list, the population, blah blah blah, list inside a list. That's totally fine. And then we've done slice notation before, but here's a quick reminder. This is our list above here. So United States slice 0 is the population. United States slice 3 is the fourth item, so that's the list of cities. United States -1 is the last item, so that's the list of cities again. 1:3 is start at index 1 and go up to but not including index 3. So that means start at index 1, go up to but not including index 3. So it'll be a list of Washington, D.C. and New York City. Nothing :-1 means start at the front of the list and go up to but not including the last item. So it'll be a list of the first 3 items in the list. And then 2:0 means start at item at index 2, which is New York City, and go all the way to the end of the list and get everything. So that'll be the last 2 items. So if we run this, and hopefully that's what everything I said it would be. If you access an index that doesn't exist, that's an error. List index out of range should be pretty straightforward to debug. We use append to add to lists, and we can use pop with an index to pull something out of the list. We remove the item at that index. Pop 1 removes the item at index 1, which was banana. So then you can assign it to a variable. This is the value that I pulled out, popped fruit, that's banana. And now fruits equals only apple and cherry. And now we'll talk about tuples. Tuples are like lists, but immutable. A tuple is defined using parentheses instead of brackets, but otherwise it functions like a list that you just simply cannot add or remove items. So here's the United States. I had it as a list. Now I have it as a tuple. It's basically the same, except it's now surrounded by parentheses. We can slice the tuple with all the same ways we sliced the list. And I think what we're missing here pedagogically is you cannot append or pop on a tuple. So US tuple dot append 42, US tuple dot pop 0. That doesn't work. That doesn't work. Oops, that's markdown. Okay, so this doesn't work. You use a list when you're like building a list of data, kind of like if I'm like, let's say I give you a file that has names in it, and you're building a list of what names are in that file. So you keep adding to the list, right? You're modifying it. Tuples are more like for constants, like where it's like, I have some data, I have a list of names of people who are coming to my party. I know the names ahead of time. It's always going to be the same people. So you stick them in a tuple because you don't need to add anyone, you don't need to remove anyone, So you would do something like, in that example, it would look something like, an example I just talked about. It would look like something that's like, guess equals, Brad. Yeah, perfect. And like for guess in guess, print, I hope, yeah. So like that doesn't need to be a list because I'm not adding anything to it. I'm not removing anything to it. And technically, tuples are more performant than lists in Python because Python can store them in a certain way because it knows they never grow or shrink. So it might be an issue if you're like processing millions of rows and stuff. You want to store them as tuples and not lists. And it's kind of good practice, just like if you're doing an example like this, like to use a tuple instead of a list, But if I was going to say like, what time are they arriving, then I need to like compute that. I would need to put that in a list because I'm like adding, as I compute each time, I'm putting it into the list, So, yeah. You'll see people use tuples a lot like this, like for like simple constants, lists of data, stuff like that. That's not going to change. And then here's this random, weird, strange thing, which is just very funny and weird. But because you can use parentheses as grouping in Python, you can use them anywhere to group things together. Like here, like n equals 3 plus 3, I put parentheses around it. Does that make it a tuple? No, it's just 3 plus 3, right? Here's apple. That's just a string. With parentheses around it, it's still just a string. But if I use a trailing comma inside the parentheses, now it's a tuple. And this is also a tuple because it's a string and a comma and another string in parentheses. Because this, and you can think of it that way because this would not make sense on its own. Banana, comma, apple, right? That doesn't make sense on its own. So when I see the parentheses, I know I have a tuple. So I print these. N is 6, 3 plus 3. A is apple. A again is still apple. A tuple is this thing. Apple, a tuple with a single item. And fruits is banana, apple, which is a tuple with 2 items. So I did like, so I go to a tuple.
That one's a possible start. It can make sense. Yeah, that one. And then actually the same place I'm doing my project on over there. It's in Oakland, right on 12th Street.
So see, like, a tuple length is 1, and the fruit's length is 2. It's a tuple with 1 item and a tuple with 2 items. What do you think the length of n is? Any guesses? N is 6, right? So what's the length of n? We have 6. Any other guesses? 1? Is that a guess of 1? I guess it's going to be an error. I think it's going to be an error. I'm not even completely sure. I think it's just an error. Like, cannot find length of int or something. Yeah, object of type int has no length. So, it was kind of a trick question. But this is like what I was talking about, actually what I was talking about earlier with like tinkering, like, hey, I wonder what the length of n is. We'll just try it, like see what it prints out, see what error you get, like, yeah. Okay. And sets, we're just going to cover real quickly. Unordered collections of unique elements. So unique elements. So that means like if you have the name Travis, it can only appear in the set once. So we can define sets in a couple of ways. We can pass an iterable to the set constructor. So here we have a list, and we turn it into a set. Or we could use these curly braces, which are the same as we use for dictionaries. But here, it's more of looks like a list. There's no like colon, you know what I mean? So because we don't have that, it's not a dictionary, it's a set. So we print the set, and then notice that it printed out in a different order than when we defined it. We defined apple, banana, cherry, ABC. It printed out cherry, banana, apple. Why is that? It's because the order of items in a set is not defined. Sets do not have order. It's like a bag of values. You just reach in, you can pull out anything. If we try to add another banana, nothing happens. But we can remove the banana, and then we would just have cherry and apple. So here is, well, let's just do the first part. So I can run this as many times as I want, and it never adds a new banana. Unique items. There's a question?
So sets don't have a defined order. Does that mean that it's a randomized order, or will it always?
It's an undefined order. It's not one that's predictable, but it can sometimes be consistent within the same program. So it's not random. It doesn't like get shuffled every time you try to look at it. You know what I mean? But it's just like looking at the code, you don't know what order they're going to come out in. Whereas like a list, you know what order they're going to come out in because it's like they're in ordered sequence, you know? And the second one shows if I remove banana, then I get cherry and apple. You can't remove an item from a set that's not present. It gives you a key error like in a dictionary. And we can use the in operator to check if an item is in a set, which also works for checking if a key is in a dictionary. Apple in fruit set, true. Apple in fruit dict, true. So I can see if I'm trying to create this set, it's got a bunch of duplicates. When I print it, the duplicates are gone. And that's kind of the point of a set, because it's kind of like, let's say we got the countries, right? So like, let's say you're at an airport and there's like 10 customs officials and they're all stamping passports, and it's like, okay, you're from Germany, you're from Germany, you're from Vietnam, you're from Russia, you're from China, you're from Poland, right? And they're stamping passports. And then what if we wanted to take the list of countries that each person had, plus the list of countries from everyone next to them, and say, what is the total list of unique countries that we saw, right? Like, what are all the countries that people came from? You don't want to see, like, Germany, 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 India, India, Poland, 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 right? You just want one of each. So you just take that whole list, toss it into a set, and the set reduces it to just the unique elements. That's where sets are really useful. Okay, this is at least 10 lines long. That's just like reasonably long. Okay, here's another exercise. Write a data model that is reasonably long, that models a real-world thing or things, and it contains all of the data structures we've discussed: a dictionary, a list, a tuple, and a set. Try pulling some of the data out of your model and assigning it to variables that you print out. Bonus points if you define a function and use it for assigning some of your data. So here's like kind of an example. There would be more here. Don't use sea creatures because that's what I used. And just some real world data. It could be a deck of cards, countries, figure skaters, Olympic athletes, Olympic sports, anything. It could just be any kind of thing. People who live on your street. Does anyone understand the exercise? Okay, then I'll give you a few minutes to try that out. Okay, how'd everybody do? Feel pretty good? Yeah? Alright, I think that's enough of that. Let's talk a little bit more on for loops. So, in other languages other than Python, we often make for loops with a loop variable that counts how many times you've been through the loop. This is some JavaScript code where we're saying, here's this variable I, it starts at 0. We're going to continue the loop as long as I is less than the length of the data. I++ just means keep adding 1 to I. And then we process data I, data 0, data 1, data 2, you know. Data is like, it's an array, but it's like a list in Python, right? So we're using this I variable. It keeps track of where we are in the list. We're at index 0, we're at index 1, we're at index 2, blah, 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 right? Meanwhile, the for loops we've seen in Python just give us the things out of the list. For fruit and fruits, print fruit, right? Apple, banana, cherry. But what if like the first 3 fruits were regular price and the rest of the fruits were on discount or whatever? We would need to keep track of where we are in the list. So we can do that manually, you know, verbosely by defining our own loop variable. So here I set I equal to 0 for fruit and fruits, just like before, right? For fruit and fruits, for fruit and fruits. If I is greater than 2, so if we're past index 2, you know, 0, 1, 2, those are the first 3 things. If we're past index 2, we say it's on discount. And then otherwise, we just print the fruit. And at the end of our for loop, we add 1 to I. So as we're going through the loop, I starts at 0, the index is 0, then we do our code, then we add 1 to I, now I equals 1, we're at index 1, blah, blah, blah. And we can just kind of keep track of it that way. Which is fine, and it works, but it's kind of verbose, and it's very easy to forget to do this, to add 1 to the I, right? Like, so if I run this, it prints apple, banana, cherry, and then discount, date, line, pair, right? But if I had forgotten to do this, oops. Yeah, if I had forgotten to put the I plus 1, then now I is always equal to 0, which means it never puts the discount. So that's like a bug in my code because I forgot to put I plus equals 1. Okay, so now what Python gives us is the built-in enumerate function for keeping track of the index of items as we go through a for loop. So the enumerate wraps an iterable and produces tuples of index and item. It's more succinct and much less error prone. So now my code looks like this. Compare that to up here. Now I say for I comma fruit in enumerate fruits. Remember before I was just doing in fruits. Now I'm saying in enumerate fruits. And then I say, if I is greater than 2, discount, else print fruit, right? So this ends up with the exact same list I had before. The code is equivalent. But in this case, I don't have to keep track of this I, this index variable, myself. I don't have to keep track of it manually. And we also see that the left side of this for loop here, I could have put this in parentheses because this is technically a tuple. And I'm saying like, take whatever this returns and put it into this tuple where the first thing gets assigned to I and the second thing gets assigned to fruit, right? So that gives an example of unpacking. So here I have like x comma y equals 50 comma 500. If I print x and then I print y, the first item got assigned to the first variable. The second item got assigned to the second variable. Here I have 3 fruits, and I say LBP equals fruits, and when I print them each out, it's lime, banana, and pear. And actually, if we assigned if I assign the result of enumerate to a single variable and print it, I get a bunch of tuples. the index and the item, because that's what enumerate returns. It returns tuples. This is just kind of what we call syntactic sugar, which is just like a concise way that Python lets you write, oh, take that tuple and put the first item in I and the second item in fruit. And because that's what I was demonstrating down here too, right? Like take this tuple, put the first item in X and the second item in Y. Take this list and put the first, second, and third items in L, B, and P, you know? Line, banana, pear, line, banana, pear. Cool. All right, any questions on enumerate? Okay, let's talk about exceptions. Okay, Python has the concept of exceptions. They interrupt program flow and represent a condition that a running program either didn't expect or can't recover from, an error. Exceptions cover everything from incorrect program syntax, performing operations on data types that don't support them, like when we tried to append to the tuple, or attempting to read data from a list or dict at an index that doesn't exist, trying to read in a file that is missing. All these things can cause exceptions. Now, I know we haven't talked about object-oriented programming yet, which makes this a little bit dicey, but exceptions, all exceptions in Python are subclasses of base exception. And then base exception has another subclass tree starting with just exception. So basically, base exception is like the absolute root of all exceptions. And just the word exception, just the exception class, right? That's kind of like exceptions that we should be catching and handling and dealing with. Because base exception includes things like system exit and key interrupt, which is like if you're running a Python program and you hit Control-C, it sends a keyboard interrupt to the program. That's technically an exception, and you can catch it, and like your program can catch it and say like, no, I'm not being interrupted. Screw you, blah blah blah. But like, really, you don't want to do that. Like, you want, if your program's running, you want someone to be able to interrupt it from the command line, you know. So usually we deal with just the exception class, not the base exception class. But in some cases, like a server or something, you do want to catch any kind of exception, any kind of interruption, and like deal with it a certain way. So that's why it lets you do that. So anyway, what does it mean to catch an exception? Well, let's look at an example. Here I have some number strings. I'm going to convert them into actual numbers. I run this code and boom. Invalid literal for int with base 10, x. Because there's an x hanging out in my number strings list. Or it's not a list, what is it?
It is a
Tuple, exactly. So anyway, so I get this exception, right? Like there was data that you didn't expect. There was an x in there instead of a number. It causes this exception. And what happens is when the exception happens, all program execution stops immediately. Python looks for any handlers that you've attached to your program for handling the exception. And if it doesn't find any, the exception gets raised. That's what we call it. They get raised up the stack. Because you like think about when you're calling functions. You call a function, it calls a function, it calls a function, it calls a function, right? The exception gets raised up that stack. And if it hasn't been handled, it crashes the program, basically. You see the exception at the top level. So, and the program crashes, basically. It halts the program. But it's better than crashing, though, right? Like, have people worked with like C, C++? You don't know what a seg fault is? No? Maybe I shouldn't tell you because you don't want to know. But a seg fault is like if like a C program accesses memory in a way that's not good, it just like dies and crashes and it says seg fault, core dumped. And that's all it says. You're like, well, what caused it to do that? What is happening? What crashed? Where was the problem? You get none of that information. Whereas in Python, we see here it's like giving us this nice message like, oh, this is what happened. You tried to convert x into an integer. Like, it happened at this line, exactly. So that's actually really useful because then we can debug it and figure out what was our program doing that caused it to have this happen. In this case, we would look up here and say like, oh, there was an x in our data, But so I was saying before that like the whole point of exceptions is that it gives us a way to reason about and respond to errors, right? So how can we like respond to this error? What we use is the try except block. So here, try, that's a statement, right? It takes in a block. This is like the indented code here is a block, right? And what's in the block is the code we want to run. Then, as part of the try, notice that this is on the same line, right? The except here is on the same line as the try, or the same indentation level. It's not on the same line, but it's at the same indentation level as the try, right? We say, try to run this code. If a value error happens, except value error as e being a variable that holds the error, then we're going to print could not convert some values, and we're going to print the error. And then our program will actually continue. It'll say done converting numbers, and it'll print the numbers that were converted. Let's try that. So it's running along, it converts the 1, it converts the 2, it gets to the x, could not convert some values, which is what it prints out, right? And notice that the right side of this, invalid literal for int blah blah blah, is the same thing we had up here, right? That's the error message that we printed out here. By simply converting an exception object into a string, which happens when you print it, you get the message. So it's really simple like that. You don't have to worry too much about it. Then it prints done converting numbers. Then it prints the converted numbers, 1 and 2. What happened to 4? Go ahead.
It stopped at the exception.
Exactly. It stopped at the exception. The exception happened. It said, just like I was explaining before, it says, okay, wait, there's an exception. Is there any code to handle this exception? It says like, oh, there is. Okay, then do this. And then it just goes to the next line of the program, done converting numbers, right? Like it doesn't, there's no code here that says, oh, go try to do the other stuff you were doing again, right? If we wanted to do that, we'd have to put it in like a while loop or a for loop of like, keep doing things, and we'll see that in a second.
Well, this is a for loop.
It is a for loop, yeah. But when it gets to this code, the exception takes you into the except block. So it doesn't re-enter the for loop. The for loop would have to be outside the try, which we're about to see. So here's another way of doing it. This time, like I just said, the for loop is outside the try, right? So now we're saying like, go through every string in the number strings, right? Try to convert it. And if there's a value error, put it in the rejects. So this means that when the exception happens, it goes to the except block, and it puts string, which we still have, into rejects, which is a list over here. Notice that we're using lists because we're building them up, we're adding things to them, right? And then when it puts the reject in, it gets to the end of this block, right? And it says, okay, time to go to the next thing in the for loop. So when we run this, converted 1, 2, 4, but found 2 rejects, x and foo. So that's kind of more useful, that version, right?
If there's more than one exception, you can log them all at once rather than,
We're getting there. Generally, you should only catch exceptions if you intend to do something meaningful when they occur. Even if that means just logging it, you should not catch an exception just because you know like, oh, this could catch this could throw an exception. I should put like except key error, except index error, except attribute error, except name error. Like you should not have those like all over your code just in case some of your code is wrong. Like if your code is wrong, you should let it be wrong and then fix it. This is for like exactly this situation where like I've got a million lines of numbers that I need to convert to integers. I don't know what's in that file, so I'm gonna like start converting and then handle the exception because I know it could occur. But this isn't like, oh, I get a name error because I didn't define a variable, so I put it in a try except so I don't get the name error anymore. Because then it's like, yeah, but your code's not doing anything useful because it's still not assigning that variable or whatever, you know? So you should only catch exceptions if you intend to do something meaningful when they occur, even if that means just logging them. And it's possible to swallow exceptions. So here, I said my num equals my number's 5. Well, there's nothing at index 5. So that's an index error, right? But I caught the index error, and I just said pass, like do nothing. So basically, I define the numbers, it tries to get a number at index 5, which doesn't exist. It catches that exception, but then when it tries to print the number, now it's another exception. My num is not defined because it never finished this assignment, right? As soon as it got over here, it raised the exception, which got caught by this except block. I mean, I could put like, imagine this, right? I could put like try except name error, pass, right? And now it's like, okay, what did that program even do? It tried to do this, it failed, and I said don't do anything. Then it tried to print the number, but that didn't work, so it did nothing again. It's like, is that really useful? Like, it's not. Now it's just you're skipping random parts of your code because you don't know how to handle the error. That's not the right way to do this, you know? So notice that I use this pass keyword. I've brought it up in other lectures. I mean, we're repeating lectures now, so I've lost track of when I've said things. But pass is a special keyword, which means do nothing, no op. It literally does nothing. So for example, if I'm like writing a bunch of code, right? I'm like down here, like, you know, yeah, I'm writing a bunch of code. Yeah, blah, 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 right? And I'm like, oh, I need to call myfunc, yeah. And then I go up to define myfunc, and I'm like, yeah, I'm going to define myfunc. Okay. And then I'm like, wait, what should myfunc do? I'm not sure, but I want to run this code right now, right? It says indentation error, right? What's the problem? Because when I use the colon here, I need to introduce a block. Python will not let me just have a function defined with nothing in it. Whereas, like, you know, if you think about like JavaScript, you have like function on click, and you can just have nothing in it, right? But you can't have that in Python, so that's why we use the pass keyword. So the right way of doing this is pass. So it's like myfunc does nothing. Okay, great. Well, maybe we'll come back later and write some code for it, you know? That's the main reason you use pass. Also, if I had like a for loop, like for fruit in fruits, and I was like, you know, get fruit price fruit, you know, I don't know, something crazy. P equals get, and then I was like, oh wait, P divided by 10 minus 10. Oh wait, that's a division by 0. Wait, hold on, what's going on with this function? And I'm like, looking at it, I'm like, wait, I just want to comment this all out, right? Well, now I've got a problem again. Because this cannot be empty. I have to put a pass. And then it's fine. So if you comment everything out of a for loop or everything out of a function, you need to remember to put a pass so that your code doesn't crash. That's all. That's what pass is. All right, back to exceptions. So we can catch multiple exceptions in the same except block. So here I have, I'm converting numbers, and I'm trying to get index 100 of converted, which isn't going to exist. So that's an index error. So I'm saying if a value error or an index error happens, then print that. So this time it was the index error, list index out of range. Cool. And I can also have separate blocks for each exception or groups of exceptions. So I could say, if a value error occurs, say could not convert some values. If an index error occurs, on the other hand, say one of the index was not valid. So when I do this, now it says one of the indexes is not valid. Oh, and notice that now I'm using a list comprehension, which doesn't help with the, I really do want the for loop and the try inside the for loop if I want to do it like the good way that we saw, because the list comprehension is just going to die halfway through. It's going to be like the first example, right? But anyway. Oh, and yeah, if we don't need, see here it's printing E, the exception message, but if we don't need the variable E, we can just leave it out. Just like if an index error occurs, I don't care what the exception was, this is what I'm going to do. I don't need the object, you know. So. As E takes, basically says, if there's a value error, put the error object, because like there's like when an exception is raised, it's an object is created and raised like up the stack. So as E says, give me the object that is the exception and put it in the variable E. And we use it like up here. We use it up here. We put it in a format string, and then it prints the exception. Like that's the exception message. Invalid literal for int with base 10. So because we got that object as E, we can print it out. But if we don't need it, what I was saying just a second ago is like if we're not using that variable, right? We don't need to put the as E. And this one, I think this one is missing a explanation. But this is like, so we can value error, name error, key error, all this stuff. These are all built into Python. They're all always available. You don't need to import them. And I can just say like, I'm trying to say hello to Alice. And if name is not equal to Bob, raise value error, not Bob. So that will raise an exception. So this is not a great example of this. It's more like if you're expecting a list with 5 elements and someone passes you a list with 6 elements, you just raise an exception and say like, hey, list was supposed to have 5 elements, dude. You know, like, so that's kind of what that's for. Okay, and then we can re-raise exceptions. This is exciting. So now, this is one of my awful convoluted examples where I try to introduce too much stuff in one example. All right, let's do it. So we're still converting strings into numbers. Here's main. This is the main function. So let's start there. We've got the strings, and we say parse all strings, and we print numbers are numbers. That's what we want to do, right? So we go into the parse all strings function. It's right here. For string and strings, try parse string. Okay. And parse string is try return int s, except value error. It prints, and then this is what I was talking about, the re-raise. It raises the error back up. So re-raising is like, I know this exception might happen. Oh, it happened. Okay, I need to do something. Like I need to clean up the database, or I need to call my mom, or I need to log a message. Something has to happen, right? But then at the same time, I handled it, I caught it, in my accept block, but I don't know what to do now. Like, I can't continue with my function. Like, now that I just closed the database because there was something wrong, so now I can't continue. So then you re-raise, because then you're saying, like, I did as much as I could to clean up after this, but now it's your problem, whatever function called me, you know? So here, when I pass in a string that's not an integer, it's going to parse string, right? This is going to cause a value error. It's going to print out that it's not an int. And then it's going to re-raise. So the value error is going to go back up here, right? Because that's where I called parse string. That's in a try except block, right? But the except is for index error. And you see the comment, this error never happens. So the value error doesn't get caught by this except block, right? So we were talking before about the algorithm of how Python figures out how to handle the exceptions, right? Like, it keeps looking for a handler up and up and up and up. It raises up the stack, right? So the value error happened. It found a handler. But then the handler said, no, re-raise the exception. Send it back up. So it gets to here, and it's looking for a handler. Well, this is a try except, but the handler is not for value error. So that doesn't mean anything. It's going to skip it. So it passes it back up to partial strings. So it gets passed up here, the value error, right? Here we have a handler for value error. It says, not all strings can be parsed, and it prints the message. Error is handled, don't re-raise. So we're done, right? And then in the main, when we call main, we have some except blocks, but the error was already handled. It wasn't re-raised, so that's not going to trigger anything in our try except for our main. All right, I'm going to run this, and I'm going to talk about it one more time. Okay. So here's our numbers, 42, 34, x, 100. So when it gets to the x, this raises the value error, right? And it prints out x is not an int, right? But then it re-raises. And we said it's not an index error, so it doesn't get handled by this code. It gets handled by this code. Not all strings could be parsed, E. Not all strings could be parsed, invalid literal, X, right? And then it prints program done. We'll talk about that in a second. So does everyone understand why we re-raised the value error here? Why did we re-raise the value error here?
So that we could get a more, I guess, more visibility over what's actually happening, rather than just like, oh, an error happened. It's like you re-raise it to the top, so it gets to the part that it gets handled by.
Yes, exactly. No, exactly right. It gets handled by the part that knows what to do, right? Because look, if you look at this function, parse string, it's just all it's doing is taking a string and turning it into an integer, right? If it can't do that, like there's nothing else it can do, right? It doesn't know what to do after it can't parse it into an integer, right? So it just prints out, it logs like, hey, I tried my best, and then it has to re-raise so that you get up to the part here where the value error can actually be handled, and it says not all strings can be parsed. That's exactly right. Do we all understand why except index error doesn't get stopped there? Why doesn't it get, I'll do it again. Why doesn't except index error catch the exception?
It's not an index error?
It's not an index error. Very good. 100% correct. Exactly right. So it just skips it because it's not an index error. All right. And all right, what if I What if I do that?
It'll catch it.
And what will it print?
The value error occurred.
Will it still print not all strings could be parsed?
No, because it'll operate on the first operatable thing it comes across, maybe.
Right.
So I have no need to keep going up.
I didn't re-raise the error here, right?
Yeah.
Oh my God, Copilot, you're going nuts. So if I had raised it, it would then gone to this value error block, you know what I mean? But because I didn't raise it, it's done, right? It's been handled.
Yeah. Can I ask something?
So if I run this now, it just says X is not an int, a value error occurred, numbers are none, program done. Oh, because partial strings doesn't even actually return numbers. I never even realized that. Numbers are still no. Oh, it has to return it too. All right. And now it's operating more like our original program, 42, 34, 100, because what we're saying here now is like, oh, if a value error happened in parse string, then, you know, we want to, this might be a good spot for pass, because we just say like, oh, skip that value, you know. It got logged, so we can just like pretend it didn't exist. So here, boom, boom. Okay. And then, do you have a question?
So the only reason it skipped the first time is because none of the, to catch it applied, so it just kept going forward anyways. Even if we have that, so now we have something that would catch that value error, can we still raise it even though it's caught?
Where? Where do we want to raise it? Oh, you want to put this back? This back? Yeah.
Yeah, except value error.
Yeah.
And then we had it like perform a task. Could we still raise it?
Yeah, that's the idea. Yep.
Okay, gotcha.
We're gonna raise it again,
Just so.
just like we did here, right? We caught the value error, we printed something, and we raised. And this print doesn't. This could be like db.close, you know, call your mom, you know, like whatever you need to do.
Okay.
Okay, and then there's one more thing I want to talk about, I think. Okay. Is this finally? So finally is also part of the try, just like, you know, like an if statement can have if, else if, you know, have multiple clauses to the statement. The try can have, starts with try, can have as many excepts as you want, and then it can have one finally. And finally is very well named because it means that no matter what happens in all the above code, the finally block runs. So if there was an exception, after we're done with the exception code, we run the finally code. If there was no exception, then after we're done with no exception code, we run the finally code. So this is like your catch-all for like, hey, I need to close this database no matter what. I'm running my program, open the database, do a bunch of stuff, try, do a bunch of stuff, finally close the database. You don't actually even need to have an except block for a finally. You can just have try finally. Because then if the exception happens, the finally happens, and the exception crashes the program.
Gotcha.
Yeah. So now that's why it said program done. If I have a re-raise here, that's going to crash the program. Whoops. Where is it? Okay, yeah. So when I run this now, it says program had errors because it's accepting exception. And if you accept exception, it means any exception. If I get rid of this, it prints all my error handling code. It prints program done because it did the finally, right? But it crashed. Here's the exception. invalid literal for int, you know? So I know this is kind of a convoluted example, but I think it illustrates a lot of cool stuff. I'm trying to put it back the way it was before I do the next lesson. Okay. Oops, this is what I want. Okay. Okay, this is me talking about it. I talked all around about it. We're done with that. Okay. Okay, we can define our own exceptions. So this is a little bit, just a tiniest taste of object-oriented programming. What I'm saying here is, let's create a class. Classes are how we create objects. A class is like a template for an object. So I want to create a playground exception. So I define the class for creating playground exceptions. In the parentheses is exception because the playground exception inherits from exception. It is an exception. But the body of the class is just pass, because all I'm saying is like, hey, there's a playground exception, it's an exception. And I give a couple more exceptions, name not given error, and I say that's actually a playground exception, which means it's a playground exception, which means it's an exception, right? And location missing error is a playground exception, which means it's an exception.
So you can make it all function, go through the same operating function if it catches it, rather than having to repeat, oh, do this, do this.
Yeah, partly that, yeah. I mean, the main purpose of doing this is just so I can have my own exceptions that I can reason about that make sense to me, right? Like if you just keep throwing value error everywhere, people are gonna be like, if you say like, value error, your credit card is expired. How is that a value error, right? It should be credit card expired error, right? So you can define your own exceptions that make sense in your program. So here I have a bunch of students represented as tuples. Okay. So I'm going to do a roll call for student and students. If student 0 is none, so the 0, index 0 is the name, right? So if 0 is none, it says name not given. If student 1 is none, it says location missing. And otherwise it prints student name is at the student location. So I call roll call. It says Alice is at the slide. Bob is at the sandbox. These two are good. And then it craps out with an exception. What's the exception? Location missing error is not defined because I forgot to run this block. All right. Let's try it again. Okay, here we go. So it says playground error, no location, which is this part, right? So the thing I'm trying to illustrate here is that student 1 is none. That's Claire, none, right? We don't know where Claire is. Here's an example of none, right? So if I'm saying if student 1 is none, I'm going to say location missing error, no location, which is what got printed here, right? But notice that there's no, I'm not catching location missing error. Why did it get caught? Why didn't it just crash the program? If you can get this one right, you don't have to come to the object-oriented programming lesson. So don't worry, that's kind of a tough question. It's like basically it's printing out this part, right? Playground error, right? So it's catching the location missing error as if it was a playground exception. Why? Because location missing error is a playground exception. Right? So when I say catch any playground exception you see, well, location missing error is a playground exception, so it counts. Meanwhile, let's just give Claire a location real quick. Actually, I'm going to comment her out to make it more clear to myself later. Okay, so now we have none who's at the slide, right? This is going to be a name not given error, right? So now let's see what it prints. Error, missing name. which is this one, error, missing name. So name not given error is also a playground exception, right? So why did it print this one instead of this one?
Because it was defined as the second.
Yes, because it was defined first. It's the first one it saw. Exactly. So it goes through these in order, right? Because it's like, oh, I got a name not given error. Do I have a handler for name not given error? Yep, I do. Okay, then do that. It doesn't also do the playground exception, right? It only does the one that it matches. Whereas when we did the location missing error, it was like, okay, I've got a location missing error. Is it a name not given error? Nope. All right, let's see. Is it a playground exception? Oh, yeah, it is. So we can just do that, right?
Yeah, it takes
Cool.
the path of least resistance.
Well, yeah, it just does them in order. And actually, this is what you want to use to your advantage because you want to say like, well, if a name not given error happens, that's a big deal. And I need to, find out get this person's birth certificate or something, right? But if it's just a playground exception, I can keep going or whatever. You know what I mean? Like any other playground exception is not such a big deal. You can kind of like build in logic like that, Yeah. And then I have exercises for exceptions, but I think that we can just kind of skip these. You can do them on your own if you'd like. And if you want to send me the Python notebook where you did them yourself, you can send it to me. I'll look at it. No problem. Feel free. But I'm just going to end the class here. I'm not going to.
Do we email it to you, or how do we get it?
Yeah, the best way would be like Discord, but that's probably the best way. I think I set up a Dropbox at one point, but that seems really convoluted.
So just post it in Discord.
You can post it in the Python channel in Discord, or you can open a direct message to me and just drag it in there. And it'll just go right to me, and I'll look at it. Cool. All right, that's it for today. Thank you all for coming. And are there any other questions about, let's see, what did we talk about? Literals, expressions, statements, none type, dictionaries, slice notation. What are valid values for dictionary keys? Can dictionaries be nested inside each other? Yes. Using expressions to populate dictionaries. Creating a new key in a dictionary. Using enumerate and list. List slice notation. Tuples. Sets. Creating data. For loops. Enumerate. Tuples. Unpacking tuples. Exceptions. Any questions? The whirlwind of everything we did tonight. Go ahead. If you have questions, go ahead. We have time.
I'll review it again, but the slice notation kind of went right by me. So.
We can spend more time on it. We can do it. We can do it right now. Okay. Let me create a new notebook so I don't get too confused. Okay. So let's create a nice juicy list. List of, someone name an object.
Square.
Square? A list of squares?
What?
Shapes? How about shapes?
Okay.
Shapes equals circle, square, triangle. We need more. Rectangle, hexagon. Shout out shapes.
Okay. A little bit of Copilot.
Duodecagon. Okay. Yeah, Copilot's helping. Octagon. Sure. Pentagon. Nonagon. All right, there we go. Now we're getting it. I need to. All right, so we have 10 shapes. That's not gonna work. Okay, whatever. Format. Notebook. Yeah. whatever. Oh, good. Did that work? No. Okay, anyway. All right, so we got our shapes. So, so we do shapes 2. This is the most simple thing, right? Actually, let's do this. Let's put the indices next to everything. So it'll be really easy to see. So this is 0. This is 1. 2, 3, 4. Just watching me count. 5, 6. I'm probably going to use this again, so it's good. It's good to get it out there. 8, 9. Okay, so those are on the indices, right? Or indexes, as some people say. So I say print shapes 2. It's triangle, right? Because that's 2. Great. Print shapes. Do we understand that? We get that right? Just get it by the index. It has one index. That's the thing at that index, right?
Yeah.
Cool. Okay, now I can do -1, which is decagon. So this is also -1. If I do -3, what's it going to print? What? Pentagon. Let's see one. Yeah, I think so. Yes, good. So this is -3. Okay, now we can do ranges. If I do print shapes 2 through 5, or this would be slice 2, 5, I guess you would say. It's going to start at index 2, so I'm going to get triangle. And it's going to go up to but not including 5. And the way to think about it, when you think about does it include 5 or not, is that it's going to give you 3 elements, 5 minus 2. So it's going to give you 2, 3, and 4. So this should be a new list that has triangle, rectangle, and hexagon. Okay. So that's basically how that works, right? We can also omit some of these. So if I do like nothing, see there's literally nothing here, right? Just :5, nothing :5, it's going to start from the beginning of the list. So it'll be circle, square, and then triangle, rectangle, hexagon. Make sense? Okay. And then I can also omit the second one. So I go from like 6 to the end. I get octagon, pentagon, nonagon, decagon. That makes sense? Okay. I can also combine, I can still use the negative indices here. So I can do 6, I'm going to make this its own line. So what is that going to print? This one takes some thought.
It would print.
So it's going to print, it's starting at 6, so it's going to print octagon.
It would stop at nonagon, but not including nonagon.
So it'll be a list of octagon, pentagon, right?
Yeah.
I think so too.
So
This was supposed to be.
the negative number is it starts from the very
The
bottom,
end of the list. Negative, but it's not, yeah, it's -1 is the last item.
the very last code.
So there's not like -0 as the last, you know what I mean? Like,
Yeah.
there's no such thing as -0, right? So,
I have a mini question too. So if negatives start at the bottom of the code going up, do we need to populate each one of those? So like if we did -5 right now, that would be sort of thing.
What do you mean? Like what?
Like we did
Like this?
Shapes -5, yeah. We don't have to define that, it'll just give that to us, yeah.
Just like we did -1 or -3 here, right?
Gotcha. Okay, yeah. Oh yeah, because that's in the hash tag, so it's just a note. That's where it is.
Oh, those are just comments, yeah.
Yeah, it's just letting us know that's the line that's going to go.
It's just for us as we're trying to figure out. So it starts at 4. It's like, which one's 4? You know. Okay, and then that's pretty much it. Oh, you know how I said you can. Oh, this is supposed to go here. There we go. Okay, and then that's the most important ones, really. And then you can also do like, I'm gonna print. And then you can also do like no start and no end. What do you think that does? Whole list. But actually, one clever thing about this is actually creates a copy of the whole list. So actually, if I wanted to create, if you pass me a list and I want to mess with it, like in my function, and you're passing me in the list, I don't want to mess with your list, right? I want to mess with my copy of the list. So I can use this notation to create
A separate tree of.
a separate copy of that list. Yeah. And then what else? Is there any other weird ones? And then just to let you know, because you should know in case you ever see it, is that you actually put a second colon in here, because why not, right? Get all the colons you want. And the 2 means go by 2s. So it's like the first one, skip 2, the third one, I think, yes, something like that. Circle, triangle, hexagon. Oh, it skips every other. So it's like the ones at even indexes. 0, 2, 4, 6, 8. So if I did 3 here, it would be 0, 3, 6, 9, right? 0, 3, 6, 9. Yeah. And then finally, and you can use the other indexes with this. So I could say like start at 2, go until 6, and do it by 2s or whatever. And it's triangle hexagon somehow, because it starts at 2 triangle. It's skipping every other one, so it gives me hexagon. But then it would have given me octagon, but it's not including 6. You know, so it's like, but. Don't get so confused by this that you forget all this, because we did really good on these ones. And then the last one, this is actually cool, and I have to show it, is this. What do you think that does?
Starts from the end.
It doesn't start from the end, it starts from the beginning, because there's like nothing at the beginning. And it goes to the end, but it goes in increments of -1.
So it gives you the whole list backwards?
It gives you the whole list backwards. And that's just kind of like that's like a funny Pythonism. People don't know, like ::(-1). It means like reverse the list. But it gives you a copy. So if it's a big list, you're going to create a whole copy in memory. But yeah. Cool?
Yeah, that was super useful. Thank you.
Yeah, cool. All right, that's it for today. I'm going to end the video. I'm about to say, should the spiel be on the video? It should be, right? Because we want people watching the video to donate to. Okay, so I say this every week. This class is free. I'm a volunteer. I do not get paid. But Noisebridge is a nonprofit. It runs on donations. So if you appreciated the class or appreciated the space or got anything out of the lesson, please feel free to consider donating. There's QR codes on the walls, or you could go to the Noisebridge website. Thank you and have a great night.